In the videos for this week, I'm going to be talking about ancient astronomy. This is one of my favorite topics in the history of science. I think it's a really fascinating case study, at least partly because this looks like a very good place to start science. I mean, the kind of precise mathematical science that we know today. The sky presents us with a nice sort of progression of very simple problems to subtly more complex ones. So last time we talked about determining where the summer solstice is. So that's where the sun rises and sets on the longest day of the year. And as far as I can tell, every ancient culture had that very well worked out. You get subtly more complex ones like determining where the planets are going to be. I mean, that's not even subtly more complex. It's much harder to make exact predictions, although you can make rough predictions. Like people knew that the planets moved roughly along what's called the ecliptic. So there's a kind of highway in the sky that the planets move along. So you can make simple predictions, rough predictions about where the planets can be. That's relatively easy. Making precise predictions about where the planets are going to be turns out to be much harder. And then there's trickier things like predicting when lunar eclipses are going to happen, where in the sky they're going to happen, and even harder, because they're less frequent, predicting solar eclipses. So there's a kind of progression of problems in this area that people can tackle one by one and get better and better predictions about and apply math to and build up large bodies of data about. It's a really interesting place to do early science. But I want to note that the term astronomy kind of doesn't fit properly with what ancient people were doing. So when I say astronomy, what probably comes up in your mind is something very scientific, right? You're just trying to make observations and use those observations to build models that you can use to make predictions. And it's kind of a just the facts affair. But for ancient peoples, the skies were full of significance, of meaning. So the stars were typically named. I mean, the most visible stars would have been named. They're often identified with gods or other sort of religious entities. Their movements were considered to be significant in a kind of spiritual or religious way. So furthermore, watching the skies has immense practical significance for ancient peoples. So you need to know about the sky, for example, to know when to plant your crops, when to harvest them, and often how to navigate. So the stars were also used as a means of navigation, kind of universally across the world. So astronomy in the ancient world is this strange, to our minds, mixture of sort of pure interest in this fascinating world, religion, as we'll see today, politics, and some deeply practical matters. So calling it astronomy is misleading because we don't get all of those interesting connotations from the word, but I don't know a better one. So that's what we'll go with. Okay. So let's start talking about Mesopotamia. So Mesopotamia is where some of the very earliest cities emerge. It's not super clear where the first city in the world was because our records of this time are very spotty, but Mesopotamia translates to the land between the rivers. So you can see in this map here, the Tigris and Euphrates River, and this is the area where we find some of the earliest clear indications of populated, sort of dense urban areas. Cities are crucial to the development of something like science because what cities allow is a kind of, if you like, complexification of the structure of society. Nomadic peoples had extremely complex societies, but being nomadic, so moving from place to place, not settling down, and not having a kind of dense population, means that everybody has to have some general skills. Whereas you get tens of thousands of people all together living in the same place, some people can just focus on individual skills. Like we see in this era the emergence of pottery factories. So somebody's job is just to make pottery all day long. They don't really do anything else, and somebody else is growing the food for them. So that kind of specialization allows people to focus much more closely on given skills. And if you're in a science program, you know, it takes a lot of work to get good at science, right? It takes a lot of focus and specialization. You can't just do this as a hobby and be really good at it. So cities allow people to specialize in a way that's a real boost to learning about the natural world. Okay, so let's look at Mesopotamia for this lecture. Let's just take as an example of one of the cities that emerges in this area very, very early, Uruk. So Uruk looks like this today. I promise it used to be nicer. But it looks like it was established something like 3,500 BC, so 5,500 years ago. But that's kind of an estimate rather than an established fact. And it's likely that before the city's established, there are people living there, just not in a dense urban environment. So here's a reconstruction. I think this is a CGI reconstruction of what it probably looked like back in its glory days. So at its very height, Uruk held or housed about 80,000 people, which in today's terms is a small to medium-sized city, but at the time was the biggest urban area in the world. And like most ancient Mesopotamian cities, as far as we know all, the city's organized around two centers of power. So there's a temple, sort of geographically in the center of the city, there's a temple. So there's a profound religious authority that's structuring society. And there's also a king. So there's kind of dual centers of power in the city. There's a secular authority and a religious authority. You might have heard of the king of Uruk from several thousand years ago. This is where the story, the Epic of Gilgamesh, was set. So Gilgamesh was one of the kings of Uruk. Okay, so in this area, in the Mesopotamian world, cities are emerging. So that means trade becomes more important as people specialize and sort of need trade in order to live. And we see some really interesting cultural developments alongside of this. So predating the apparent development of cities, we see these things show up, counting tokens. So counting tokens are a precursor to both writing and numbers. So these different tokens would, they started off very, very simple. All the tokens were the same. If you wanted to count something, you would just sort of collect up that many objects. So if I have a flock of sheep, for every sheep that walks by me, I pick up one of the counting tokens. And then once all the sheep are passed, the number of tokens in my hand is equal to the number of sheep. And that's a representation of number. Very simple representation. So as these counting tokens are around for thousands and thousands of years, and over those thousands of years, they become more complex. So we see here a bunch of different shapes, and the different shapes come to represent different objects. So cool. So you've got these counting tokens, maybe one represents a bushel of grain, one represents a sheep or 10 sheep or whatever it is that you're counting. Okay, so you want to carry these counting tokens around, they're very handy. So what people started doing was putting them in these little clay pouches. So that large round object there is a clay pouch, and you would sort of put all your tokens in the pouch to carry them as a kind of collected whole. But that gives you a problem. How do you know how many tokens are in the pouch without tearing it open? Well, some clever person realized that you can just take the token, and before you seal up the pouch, you just press it into the pouch. So for every token you've got a little divot in the clay pouch. And you can use that set of divots as a representation of how many clay or counting tokens you've got. And then, so this is an example from about 3000 BC. It's about 500 years before, it's 500 years after the city of Uruk is founded. And then some extremely clever person realized that once you've got these impressions, you don't actually need the counting tokens. Right? The impressions do all of the work that the counting tokens were doing for you, which is to represent the number of things. So they switch from these clay pouches full of actual tokens to just a little piece of clay with the impressions on them. So this might represent, for example, the long, skinny impression might represent a clay vessel full of cooking oil or something like that, and the dot above it might represent 10. So this might be a piece of clay that represents the idea of 40 clay vessels of cooking oil, something like that. And this takes literally thousands of years. So the earliest counting tokens we found are 8,000 BC. You don't see this sort of arise until about 3,000 BC. So 5,000 years of development we just went over there. And that might seem like a long time to develop the very idea of making impressions on clay tablets. But if you've never seen, so again, this is a place where you take a beat and try to put yourself in the historical mindset, which is putting yourself in that world. If you've never seen writing before, you've never seen an abstract counting system before, this is an enormous conceptual leap. This is a really brilliant idea. So we get this transition from physical representations of one-to-one correspondence to abstract representations. And in the 1,000 years after that, we get full-blown counting systems and full-blown writing systems. So around 2000 BC, so before this, there were a number of different counting systems in Mesopotamia. Around 2000 BC, we see a kind of standardization into this one, the sort of depicted here. This is a base 60 counting system. So we have a base 10 counting system. You go 0 to 9, and then when you get past 9, you do another place. So this counting system, impressions on clay go from 1 to 59. Notice there's no 0. 1 to 59, and then you go to another place. So if you wanted to represent a larger number, you have multiple places. So this is an enormous technical advance, right? So if you're trying to do something like mathematical sciences, having a written number system is an enormous leap. Okay. And they use this, in fact, to get back to the notion of astronomy or pre-astronomy, whatever you want to call it. They use this to make records of things that happen in the sky. So here's one very early example. This is called the Venus tablet. This is from the Babylonian culture, which is a culture that develops in Mesopotamia. So the Babylonians live in Mesopotamia. And we get some of our very earliest astronomical records from Babylonia. The Venus tablet, appropriately, seems to be records of about 21 years of observations of when Venus rises and sets. So Venus is one of the brightest stars in the sky, and you can see it just over the horizon very often at dusk or dawn. So having a record of when Venus rises and sets is having a pretty straightforward, like you don't need any tools to make this observation. You can do it with the naked eye, so long as you know what time it is. And you can kind of like collect up these data. 21 years of records is not a trivial amount of observation to do. It's probably longer than some of you have been alive. And these records are transmitted for quite a long time. So the Venus tablet gets reproduced and reproduced over time. It's part of a larger collection of observations. And it's one of the earliest sort of what appears to be observations that we've found. Now, again, what I want to warn you about is projecting back into history. So right now so we think this is observations, but there's actually some reason to doubt. What I want to warn you against is projecting current scientific ways of doing things back this far into the past. We're talking about thousands and thousands of years in the past. So let me give you some reasons to doubt that these might be straightforward observations, because we can reconstruct when Venus would have risen and set back then. We've got the technology now to like look back to what it would have been visible. Some of the numbers don't quite add up. So what's fairly clear is that the Babylonians weren't using these models or records of astronomical events in the same way that we do. So here's an example. The Babylonians have what they would have called an ideal calendar. I don't know what their term for it was, but they have a calendar. Most ancient people have some kind of calendar. The Babylonians had a calendar with the following properties. 1 year is regarded as having 360 days. A month as 30 days, and every 3 years they'd stick in an extra month. So it's called an intercalary month, because as you can see, as I hope you know, the actual year is about 365 days long. And in a culture that lasts hundreds of thousands of years, the difference between 360 and 365 adds up really fast. So very quickly, if they just went by this calendar, things would have gone off very, very fast. And people would have been planting crops at the wrong time. They'd be harvesting at the wrong time. This would have been disastrous for them. So, you can stick in an extra month here and there to kind of fix things up. It's a pretty imprecise way of going about things. And in a paper by David Brown from 2000 called Mesopotamian planetary astronomy astrology. He argues that they couldn't possibly have believed that this was the correct figure for the length of the solar year or the length of the month, because, a month when the moon goes from full moon to full moon isn't exactly 30 days either. So these were people who were deeply invested in observing the sky carefully, writing down their observations. Their lives depended, literally their lives depended on getting things to happen at the right time of year. They couldn't possibly have believed that this was right. Being off by 5 days is a really large error here. But notice something about the numbers that they're using. 360, it's a multiple of 60. 30 is 1/2 of 60. And remember, their number system is base 60, right? So these numbers that they're using for their calendar are very similar to the numbers that they're using in their mathematical system. And he doesn't think, so David Brown thinks that's not a coincidence. Actually, what they've got here is in some sense what the calendar should be if it was perfect. So they've got a kind of mathematical picture that's projected into the heavens. And then the question is, what does it mean to them when reality doesn't fit this perfect picture? And this is where the relationship between ancient astronomy and politics comes in. So in many, many ancient cultures, and it seems like the Babylonians were deep into this as well, the skies are believed to have religious significance. So omens, an omen is something like a sign of something to come. So things like eclipses of the moon, the sun, or the planets appearing near to each other in the sky were regarded as having deep significance. Now, in some sense, they were messages from the gods. So, to the extent that the world, and the idea that David Brown develops is, to the extent that the world fit the ideal calendar that the Babylonians had set up, that was a message from the gods that things were going well. And to the extent that the skies didn't conform to this ideal calendar, that was a message from the god that things aren't going well. So the ideal here is not meant to be a picture of reality, but rather a standard against which reality is measured for either things going well or things going poorly. Now, again, this is a reconstruction. We don't have enough information to say precisely what was going on, what was exactly going through their heads, but that's one way of interpreting this wild difference between the Babylonian calendar, the Babylonian ideal calendar, and reality. And again, they're just too careful and too interested in what's going on in the sky to have been that wrong. So what I'd like you to think about here is, again, the difference between the goals of modern astronomy and ancient astronomy in this example. They're not trying to represent reality as exactly as possible in their calendar. What they're trying to do is decipher the messages being delivered by the heavens. Okay. Let's do a little bit more. Let's look a little bit further in history to the Neo-Assyrian Empire. Now, we've taken quite a big jump forward in history. We're at about 2000 BC before. Here we're somewhere between 800 and 600 BC. We're still in the same area, however. The early Neo-Assyrian Empire is in Mesopotamia. They expand quite a bit further than that, so the Assyrian Empire is quite expansive by the end of its. And what they did, and this is an interesting pattern that I think we're going to see over and over again in the history of science as we go through this course. So the Neo-Assyrians are, I'm not going to beat around the bush here. These are brutal people. These are people who would, if you see the Neo-Assyrians rolling up to your city, you probably want to surrender, because if you don't, they'll do things like take your skin off and pile it up outside as a warning to people who don't surrender to them. So these are very serious people, but to the extent that people were willing to accept their rules, so they come, you can see in this map the expansion over about 200 years. If the Neo-Assyrians come over the horizon and you say, "Hi, welcome, you're in charge now," they'll happily fold you into their empire without killing too many of you. And one of the things they do to kind of secure their power, their legitimacy, is to absorb and integrate the knowledge and wisdom from the cultures they're taking over into their own. So, what we see in Neo-Assyrian records are things like old Babylonian priests being consulted about what's going on in the heavens. So let's take as an example this guy, Ashurbanipal. So Ashurbanipal is pretty famous for being a powerful conqueror. He's a military ruler. He's the king. He's the sort of secular king. But he's probably more famous for having built a really big library. So the library of Ashurbanipal is one of the richest sort of sources of records from this time and place. And what you find in that library are texts collected from all over his newly conquered empire, collected and synthesized. And we just happen to have, I mean, it's really, I picked this guy up in particular because we happen to have a bunch of records of correspondence between Ashurbanipal and his wise men, the people he was consulting for guidance about what's going on in his empire. So here's a letter. Here's a letter to Ashurbanipal from Balassi. Balassi would have been one of the wise men he's consulting, and in this case, he's one of the sort of court astronomers. Okay, Balassi says the following. Concerning the watch of the moon, about which the king, my lord, wrote to me, the eclipse will pass by. It will not occur. So let me just hold that thought for a second. So there's clearly been a prediction of an eclipse here. Now, they're not certain. They know that it's a watch, right? They're like, okay, watch out, there might be an eclipse. And an eclipse has deep significance for the king. Concerning the watch of the sun, about which the king, my lord, wrote to me, does the king, my lord, not know that it is being closely observed? The day of tomorrow is the only day left once the watch is over. This eclipse too will have passed by. It will not occur. So he's worried about two possible eclipses, a solar eclipse and a lunar eclipse. And his wise man is saying, don't worry, we're watching it. Don't panic. I don't think these eclipses are going to happen, but we'll let you know, kind of thing. Okay, so why is Ashurbanipal concerned here? Well, celestial omens are the reason. So again, the events in the sky are regarded as having deep significance for especially the king. So there's in the kind of mixed in with the observations, the apparent observations of the sky, in the records that we have from this period are all kinds of these things, celestial omens. They're kind of if-then statements where if you see this thing in the sky, here's what's likely to happen. So here's one for a solar eclipse. If the normal solar disk's luminosity is diminished, ominous signs occur in the country and the gods are angry. There will be famine in the land. Okay, so that's why Ashurbanipal is worried, right? So if there's a solar eclipse, that means, according to their system of divination, things are going to be bad. Gods are angry at you. There's not going to be enough food. That's really bad for the king. So he's really going to be substantially worried about things like solar eclipses. Now, if there was a bad omen, the king doesn't have to just sort of sit down and accept it. They've got a few things that they can do to kind of like smooth things over. So there's various rituals for ordinary bad omens. There's various rituals that you can do. The one that I think is the most interesting is called the substitute king. So suppose that there had been a solar eclipse. Suppose that there had been a really bad omen in the sky. What the king would do is find a guy. It had to be a guy. It didn't have to look like the king, but it had to be a guy. Dress him up in the king's clothes, sit him on the throne, and the king quietly stands in back for a little while. A period of up to 100 days, this substitute king might sit on the throne. Now, the idea was that the gods, who are apparently angry, would punish this substitute king, not the real king. Now, the real king didn't give up authority to the substitute king particularly. He would continue to run the country from kind of in the shadows. But the substitute king would be a kind of offering to the gods. Here, kill this guy, not me. And sometimes you could encourage this process along. So some omens had a period of 100 days for their significance. And we have one letter from a wise man to the king saying, As regard the substitute king, if the farmer my lord, so they don't call the king during this period, they call him the farmer my lord. The farmer, as regard the substitute king, if the farmer my lord agrees, he can go to his fate tomorrow. But if not, he may sit on this throne for the full 100 days. So in this sentence, go to his fate means they're gonna kill him, just in case the king wants to like get back on his throne early because he's sick of waiting. Okay, so that's a kind of really rough. I'm sorry that I'm being kind of rough with the details of this. It's a really complex system. There's a whole bunch of ins and outs. So if a scholar of ancient Babylonian astronomy watches this video, I sincerely apologize for kind of messing up the details. I have no doubt. I just want to give you the kind of flavor for the role that astronomy plays in Babylonian, and in this case, Neo-Assyrian life. Okay. So divination by individuals is pretty common. So divination, telling the future, is performed in all kinds of ways. So you could sacrifice a goat and look at the condition of its liver. That's a pretty common one. You could watch the movement of birds. That's another common one. But the omens in the sky, celestial omens, are regarded as having particular significance really only for the king. So in modern astrology, for example, the movement of planets and the sun and the moon in the sky are regarded as having significance for me as an individual. Back in ancient Mesopotamia, things that happen in the sky are so important that they're regarded as really only applying to the king and the country as a whole. So the celestial omens in particular have this deeply political flavor, right, that motivates the king to fund things like astronomical research. And what we see in ancient Mesopotamia is a slow but steady advancement in the sophistication of their observations, their predictions, their models of the sky. And if you're the king who's living in this world where you believe that the sky is giving you messages about A, how you're doing, like how the gods feel about your rule, and B, what they're going to do to you, you are going to be highly motivated to keep some scholars around. You know, there are people who are specialists in this stuff who are trying to like do their best to make observations and interpret them for you. Okay, so that's ancient Mesopotamia, as much as I can tell you about it. I wish I could, there's so much in here. It's such a rich and interesting history, but this is already getting too long, and there's a couple other cultures that I'd like to get to in these videos. So let's leave it there for now.